That tattoo on your arm? It's not sitting in your skin, not floating between layers of cells, waiting patiently to fade. It's inside your immune system, right now, being actively guarded. And the guards have been on duty since the day you got inked. So how does your body keep a picture glued in place for 30, 40, 50 years, when it replaces almost every other cell you own every few weeks? And what happens the day your immune system decides it's had enough? A tattoo needle isn't drawing on you. It's wounding you. Precisely, thousands of times a minute. Each puncture drops a cluster of pigment particles into the dermis, the living layer under your skin, the one that doesn't slough off like the surface does. Your body reads this the only way it knows how, not as art, as an attack. Within minutes, immune cells, called macrophages, show up. Their whole job is clean up, eat anything foreign, break it down, move on. So they do what they always do. They engulf the ink, one particle at a time, swallowed whole into a macrophage's interior. Problem is, ink isn't bacteria. It isn't a splinter. It's an inert, synthetic pigment with no biological off switch for the cell to work with. The macrophage can't digest it. It can only hold it. Here's the part that actually explains why tattoos last decades. Those ink-stuffed macrophages don't live forever. Skin macrophages cycle through and die like every other cell. When one dies, it doesn't take the ink with it into the void. It releases the pigment back into the tissue. And within days, a new macrophage, drawn in by the same debris cleanup signals, swallows that same ink right back up. Die, release, recapture, die, release, recapture. A 2018 study using mouse models mapped this cycle directly and confirmed something that sounds almost absurd. The cells holding your tattoo today are not the cells that captured it originally. They're descendants, generations removed, still holding the exact same particles. The picture stays sharp. The staff running security has turned over completely. This is exactly why laser tattoo removal takes multiple sessions spread months apart, and why nobody's found a way to speed that up much. The laser doesn't erase ink. It shatters it, blasts each particle into fragments small enough for the immune system to finally do what it couldn't before, actually clear them, carry them off through the lymphatic system, and dispose of them for good. But macrophages can only process so much at once. So you wait, heal, let the current guards finish their shift, then hit it again. Session by session, the picture doesn't fade because ink degrades. It fades because you're slowly winning a very patient war. Sometimes years after the tattoo's healed, the skin around it flares, raised, itchy, inflamed. Not an infection. Not an allergy to the needle. Certain pigments, especially reds and some yellows, are more likely to trigger a delayed immune reaction. The body abruptly deciding a particle it tolerated for a decade is now a threat worth fighting. And for people with autoimmune conditions like sarcoidosis, tattoos can become the site of a flare, because that's where the immune system already has a standing garrison, cells primed and waiting, easiest to recruit first. The tattoo doesn't cause the disease. It's just where the immune system was already stationed. 3 things fall out of all this, and none of them are don't get a tattoo. Choose ink and a studio that don't cut corners. Cheap or contaminated pigments give those macrophages more to react badly to. If you're planning removal, expect the calendar, not the console. The wait between sessions isn't inefficiency. It's your immune system doing the actual work. And if an old tattoo suddenly changes, swells, itches, flares years after it healed, don't assume it's nothing. That's your immune system telling you something, and it's worth listening to. So next time someone tells you tattoos are permanent because ink just sits in your skin, tell them that's not quite it. Nothing about it is sitting still. It's a relay race that's been running since the day you got inked, cell after cell after cell, each one clocking out and handing the exact same picture to the next. The guards keep changing. The picture never does.